All right. Hello, LinkedIn and YouTube. Thank you so much for joining us live again today. We are going to talk about democratizing access to accelerated computing with Aaron Richter, who is from Saturn Cloud. I'm going to bring him up in just a minute, but as you're joining, we have a question for you, and this is Aaron. Aaron came up with a question, so he'll get the credit. But what is your favorite either Python or R package or library that you tend to work with? I know mine is probably in Python, it's probably pandas or some data viz packages, but would love to hear from you. So as you're joining, just go ahead and answer that question, your favorite Python and R or R packages. All right, I'm going to go ahead and bring Aaron up on stage. Hello, Aaron.
Hi, Kate. How's it going?
I'm going very well. How are you doing?
Good. Happy
I always
to be
answer that question of going, I can't say going good, right? Going well.
going good. It's okay. It's all allowed.
Yeah, so welcome to the show. Why don't you tell us a little bit about yourself? I've already asked your question, so people are going to go ahead and answer their favorite packages. I already see some coming in, but while they're doing that, why don't you just provide an introduction?
Sure. So my name's Aaron. I'm a data scientist, and really, like, I started my career more on like the software engineering side. That's what I went to school for, and then I kind of started in data science as it was like coming about and being defined as its own thing. You know, it's existed for a while, but then being defined as data science, I was able to kind of get my first data science title like that. And so like, a lot of my work was naturally then doing data pipelines, cleaning data, and then dealing with large data sets. And that was kind of when this like big data world came out, and like Hadoop and those kinds of tools. So I did a lot of work there. And then I did a lot of work in the like scientific computing area in Python. And then now I'm really excited to be in the scientific computing in Python with big data and accelerated computing. And that's kind of what my role is at Saturn Cloud. And I'll talk more, I guess, about Saturn and what we do, as we go along. But my job is really to help promote just data science in Python and allow and help data scientists use the tools that they already know to make their workloads faster, and then help teach the tools that they might not yet know, but kind of get going quickly on that. So that's kind of my job.
Awesome. All right. So how long have you been at Saturn Cloud?
It's just over 3 months now. So
you're new. You're very new.
Very new. Yes.
Does it feel like 3 months? Because it's kind of during a pandemic. So I'm sure that was
right. So it either feels like 3 days on some days, or it feels like 3 years at some other times. It just all depends. The days blur together, but then you look back and you're like, wow, it's already October. Like, I thought it was still like March 62nd,
Yeah, March 62nd. I think it's March 182nd at this point, right? It's
right.
Dragging on. So for those who are not familiar with Saturn Cloud, can you just provide like an intro for the company, what Saturn Cloud focused on?
Yeah, absolutely. So Saturn Cloud is in the name, it's a cloud-based platform for data scientists essentially to do their work, speed up their work. So we're in the kind of Python ecosystem. So we offer Jupyter servers for users to kind of spin up, do their work. And then we allow spinning up of GPUs, and we promote a lot of Dask and Rapids to do this kind of cluster computing and accelerated computing stuff. And that's the really exciting stuff, to where you can get a lot of your codes to work a lot faster without a whole lot of changes. And then so we allow we have a platform for that. And then the kind of next level from there is like seamless deployments, where users are able to take their workspace that they're already working in and then go ahead and deploy that as a daily job or a model or a dashboard. So that's kind of what we do in a nutshell.
Okay, cool. Yeah, whenever I type the word Saturn Cloud on my phone, it always gives me a little Saturn and a little cloud. So that's always interesting. So let's see. We've got some responses here. We have Kara's. We've got Potley.
Sure.
We've got Herb told me the proper way is saying going well. Steve's here. He says hello. Scott Miller says, I like pandas, but definitely want to learn TensorFlow. Marco says hi. And then Steve's asking, what kind of companies does Saturn Cloud work with?
Yeah, that's a great question. So our clients and basically the people who choose to use Saturn are all over industry. So pretty much every company will need some sort of data analytics and data science capability, and we come in to fill that gap. So we work with anywhere from healthcare companies who are doing analysis there to startups, to large corporations, financial organizations. Basically, anywhere that needs data science, and that's pretty much most companies.
Yeah, absolutely. Actually, that your last statement fits in very well with Siwar's question here. Are data scientists still in demand? Because I want to switch to data science, but I'm afraid I will not find a job. You just said most companies need a data scientist, right?
Yeah, absolutely. They all need data science, and from my own experience, I found this job during COVID, right? So if that doesn't kind of show you that data scientists are definitely in demand, even when a lot of people are having trouble finding jobs, I think that's definitely some encouragement. And even just personally, I did my program a few years back, and there was no data science program at my university. But now you're seeing data science programs everywhere, from universities to boot camps to free online resources. And so it's like that great place where it's not unknown anymore. So there's a bunch of resources for people, but then it's also in demand. So you can spend whatever time you need to get up to speed and then look for a job in data science.
Okay. Yeah, I think George agrees that data scientists are in very big demand. I think one question that might be interesting to the audience, especially those who are maybe looking for a data science position during the pandemic, can you just share, and I don't know if you can, your story of how you actually found a job? Was it through a recruiter? You could be vague if you have to, but was it through a recruiter? Was it networking? Was it applications? Just to give people some tips.
Yeah. So I mean, I found this job through applications, but I think part of the reason why I got it is because I had some actual prior connections. So I was involved with the PyData Miami conference. I'm located in South Florida, and I was an organizer for that. And I was working with Saturn for like sponsorship, and this was way before I was looking for a job. And then when I came around to it, I saw the job posting on LinkedIn, and I applied, and then we kind of connected the dots after the fact. But it was kind of an application. But we've hired people from people that some employees might have known previously. So the network really helps a lot when looking for a job.
Yeah, I absolutely agree with you. So back to the topic now.
Yeah.
Machine learning, right? What are some of the common or popular tools that companies use for computing or machine learning?
Yeah, and so that's kind of part of the question. And I saw some people, put in some packages that they use, and those are a lot of the commonly used ones. But when we're thinking about like computing and scientific computing and machine learning, especially in the Python ecosystem, there's like a core set of packages where people will use that, and data science will kind of use that stuff every day. These are great mature open source packages that are used widely. There's a lot of support for them. And I do most of my work in Python. That's the only reason I say that. There's definitely a lot of stuff in R and other technologies. But thinking about like the specific tools and packages, like you mentioned Kate Pandas as being one of your go-to packages, and that's most people's go-to package. Every notebook that I start off with is import pandas as PD.
Yep.
Exactly, right? And so because that's how you get your data, right? You pull in your CSV file, you're pulling your data from a database, you're processing it, doing like that. Other common ones would be like NumPy for the numerical processing, array processing, and Pandas uses that a lot. And then when we get into machine learning, I'd say probably the most, to me, one of the most popular machine learning libraries is scikit-learn. Regardless of language, just across all languages, scikit-learn is just a really rich machine learning library that has pretty much any algorithm that you might want implemented in it. And then thinking about, I think somebody mentioned Keras, but underneath Keras is TensorFlow. So talking about some like deep learning applications, more around computer vision and lately natural language processing, those kind of workloads, people will use tools like TensorFlow and PyTorch, or the kind of higher level wrappers around them like Keras or FastAI, or the tools that people I'd say I cover like a good chunk of data scientists with these packages. And what's great about the kind of Python data science ecosystem, and we kind of say that as PyData, is that there's a bunch of packages, open source packages that are maintained. They work together, and you can kind of find something to do what you need it to do. If you're doing geospatial analysis, there's packages for that. If you're doing some heavy visualization, there's packages for that. If you're doing time series, like the list goes on, and you can probably find a package, and you can contribute to them yourself too.
Awesome. Yeah, thank you for that. So there are plenty of tools that people can use for machine learning, for computing. And I know people love big data, right? So people love talking about big data. And you mentioned deep learning. I know once we get into deep learning, you need more data, you need huge data. what happens when your tools can't handle that big data anymore? Where do you go from there?
Yeah, and so there's definitely some challenges there, right? Like I think the reason for this is that the Python data science, like all those packages that I just mentioned, were generally written in a world where you were using a single CPU core and you loaded all of your data into memory. So if you had a 2 gig CSV file, no problem, and you can load that, and then you can kind of do stuff. So now when you move into this like big data territory, maybe you're not even pulling in a CSV anymore. Maybe you have to hit some database that's hundreds of gigs. Like the worst case is that you can't even access that data at all with these tools, because again, you would have to load all of the data into memory. Like when you load something with pandas, it has to go into memory in your computer. So if your data set's bigger than what your computer has, you can't even load it. So that's like the worst case. The best case is, okay, maybe the data set is pretty big, or you sample it down or whatever. You get it into pandas, but then when you try to start to do stuff, it just takes forever.
Yeah,
because
loads and yeah.
Exactly, or your kernel dies and you have to restart it and like all this stuff, right? And that's because again, it was written in that like single core fashion, and so those are the challenges. And so like thinking about like how do I address this? Well, it's like, okay, let me get more RAM, right? That's kind of like the solution. Let me get more hardware. You can get more RAM, but then you're still stuck on that single core kind of world. So you get to this place where you somehow need to use more RAM, and you somehow need to use more CPU cores or even more machines. And then that's when we get into some of these like distributed kind of applications and tools.
Yeah. We have a question kind of about accelerating computing for data science. There's a clarifying question. Does this mean we have latency issues when we have big data processed through machine learning algorithms?
Yeah. And so a lot of what I'm focusing on when I'm talking about accelerating computing, it's more like when you execute an operation, how long do you have to wait for it to finish? So if I say train a logistic regression model and I click run, how long does that take to finish? So the idea is to kind of accelerate that. And then and another factor in it is when we're talking about big data, another factor is like, can you even run anything? Can you even use the data at all? And so that's kind of the facets that we're thinking about with acceleration.
Okay, cool. Yeah, there's a question about Saturn here. So Shubham is asking, what cloud techniques does Saturn provide?
So basically what we provide is a platform where we abstract away a lot of the infrastructure. Because when like I mentioned, I just kind of briefly mentioned about having to get bigger machines and more cores and deal with a cluster of distributed computing. The base of that is you need computers. Like you need more computers somehow. And typically I just have one sitting on my desk right now. And so what we do is we abstract away a lot of the cloud infrastructure. So if you need more computers, the best way to get them is to rent them on the cloud. And so basically we make it feel like you're not having to deal with the cloud, really. You can just you can just say, I want a machine with 500 gigs of RAM. You can spin that up, and then you're working inside of Jupyter Lab, a familiar interface that people are used to working with, or you can connect it with your IDE. So under the hood, we do things with Docker and Kubernetes, and we do things with auto scaling and EC2 instances, and like all this stuff that data scientists shouldn't have to worry about.
I know all the stuff you're talking about, by the way.
Right. Yeah. Okay. Yeah. Yeah. Same. Me too. I can totally do all this stuff by hand.
Right now. By the way, Hugo's here. So he says that, we focus on high performance. So Hugo's from Saturn Cloud. We focus on high performance machine learning with Dask and Rapids. So I actually had a question. So we talk about Dask, we talk about Rapids, we talk about Spark. For those who are not familiar, can you provide kind of a brief overview of what are these tools and what are the differences between them?
Yeah, and so this is where I can take us on a brief history lesson. I don't want to spend too much time. Back in like I keep calling this air quotes big data world, mostly because I just don't really like the term all that much. But like back in like 2010 or whatever, right? There was no way to analyze large data sets, and that's where like Hadoop and that Hadoop ecosystem came around and introduced this concept of distributed computing on like commodity hardware. So it was really clunky. You had to know like Java or Scala to do stuff, and you had to maintain a lot of things. You had to think a lot in like a distributed world. And then kind of Spark is a tool that came along to kind of help make that like a little bit easier and a little bit faster, where really what Spark did was take that Hadoop world and like make it kind of run faster. But the thing with Spark is it's still written in Scala, so you're dealing with Java and JVM, and it's a little heavy for configuration and installation and all that stuff. And so that's why I'm really excited to work in the world of Dask and Rapids, because it really is, as Spark was an iteration on Hadoop, this world is now the next iteration on that, where it's really accessible for data scientists who are used to using things like Pandas and NumPy to get on a cluster and use distributed computing. With Dask, you're working 100% in Python. So to introduce Dask, I kind of may have jumped ahead of myself, is Dask is really, it's like a flexible parallel computing platform. Okay. Built 100% in Python, and it works directly with Python. It'll actually parallelize to the cores on your machine, because most machines will have more than one core. So you can get things running faster that way. It'll process things out of core, which means if you have a data set that's too big to fit on your computer, it'll process in chunks of that data set, kick other chunks out, and then give you your answer. But the real power is when you take that same exact code you wrote with Dask and you scale it to a cluster of computers. When you can have 10 computers, 100 computers, 1,000, whatever it is, and now you're not really bound now on data size. You can pull it, you can get a cluster as big as you need to pull in your data and then process it. When it comes to Rapids, this is another kind of paradigm shift, and that's why it's like a really cool and exciting time to be in data science, is because what Rapids does is it pushes the data science work to the GPU. So when I was talking about Hadoop and Spark, they're using CPUs, and then Rapids will, not just for deep learning, because people are used to GPUs for deep learning with TensorFlow and PyTorch, but things like data frames, things like linear models, random forest, arrays, you can do all of that processing on a GPU. And that's, again, it's an open source suite of packages that you can kind of get started with and working with, as long as you have a GPU.
All right. So let's say I'm working in Python, I'm using Pandas, and things are going slow or they're not loading. At which point will I know that I need to use Dask to speed things up?
Yeah, that's a great question. And so our thing, and my thing is, like, if your data fits in memory on your computer and you're not waiting more than a couple seconds or a few seconds for things to process, you don't feel any pain, everything, it's very, like, if things are kind of immediate and going for you, and that's all the data you have and that's all the computation that you have, that's perfectly fine. You should stay in that world, right? You shouldn't go learn a new thing, right? But most people are going to get to a place, and most organizations are already at a place where they have so much data that they can't just do that. Like, if you're sampling your data to get it to fit on your laptop, you know that you should be using Dask. If you watch your process utilization and you see only one core spinning and it's taking forever, you should use Dask. If you need to do like pretty intense like kind of machine learning training, or you need to train a bunch of multiple machine learning models, like a hyperparameter search or anything like that, you should be using Dask. And what's cool about Dask is that it'll parallelize really any kind of Python code that you work with. So it has high-level APIs for data frames and arrays and machine learning, but even if you have your own custom code that you've written, you can also use Dask to parallelize that.
Okay, cool. Thanks. I think those are really good, easy to follow indicators for when people are working on projects to know when they need to kind of upgrade. So you mentioned some of the differences between those tools. Are there any challenges that people face when they're using these tools? Are they difficult to understand? Are they difficult to use? Are they expensive?
Yeah, and so I mean, the great thing about these tools is that they're fully open source, like free to use. You can contribute to them, you can see the source code, and so like from that perspective, they're super accessible. Like that's amazing. That's what's so great about this PyData open source ecosystem, right? It's like anybody can use these tools and technologies. The most immediate challenge that you run into is if you're running on like your laptop, you need to get other hardware. So like if you want to use a Dask cluster, you now need to somehow find multiple machines. Or if you want to use a machine with a GPU, you have to kind of find one, and you have to, get a Linux machine and make sure there's an NVIDIA GPU and make sure CUDA is kind of like enabled and all that stuff is installed and working, right? So it's like you just have to get the hardware, like get your hands on it. And then once it's there, you have to kind of provision it. You kind of have to configure it, make sure all the nodes are talking to each other on the cluster. And so, there's a lot of challenge there just from an infrastructure perspective. Again, data scientists are not DevOps engineers, and we're not meant to be. We would have to learn way more stuff than we already have to learn. And so those are some of the challenges. And it's like, even when it comes to like reproducibility and trying to make sure that you have your same set of packages on all of your different computers, like installing things and configuring it, I mentioned earlier, like things like Docker and Kubernetes help with that kind of production and reproducibility, but those are things that I don't want to have to learn, again, as a data scientist, not a DevOps engineer.
Yeah, I mean, that's how we work as part of a team, right?
Exactly.
That's the purpose. So we don't have to learn everything. So
Yes.
then how can data scientists kind of access this? Do they have to work with, software engineers or DevOps, or are there other alternatives where they can kind of do this themselves?
Yeah. So the promise of the cloud is that you can just go rent computers, and that's like amazing. That really transformed a lot of data science, right?
Yeah.
But then you don't, maybe an organization might not need a staff of hundreds of IT teams because they have to manage their own hardware, but they still need a staff of DevOps engineers to manage that infrastructure. There's still a whole layer of things that you have to think about when you're working on the cloud. You have to think about the networking and security and upgrading machinery and making sure you're installing the software on them and like all of that stuff. So that's still a challenge. You still need a lot of infrastructure and kind of like resources and people to take care of that stuff. And then so that's where you have companies like Saturn Cloud who kind of build tools on top of that to now even eliminate that level of like DevOps engineers that you would need for yourself to do the data science. It's like, with Saturn, me as a lone data scientist, I can go sign up, get going, launch a cluster, launch machines with GPUs, use Dask and Rapids to accelerate my workloads without having to kind of like deal with a DevOps engineer.
Deal with? Come on.
Yeah. They're great people. I know a bunch of them and they're awesome. Okay. But they also have like a lot of things to do because they need to make sure that their applications are up and running and everything. And, we want to make sure that everybody can do their work as seamlessly and uninhibited as possible.
Yeah, absolutely. So you mentioned the concept of security, and there's a question here from Mike. So with regards to privacy, I wonder how machine learning and the experts will factor privacy into building these machines.
Yeah, so I mean, I think there's definitely a whole discussion around like hardware level security that I'm not qualified at all to speak of, but let's assume that that's there and that's taken care of. A lot of the security comes into when you're thinking about the cloud, right? Because the cloud is a place where they're hosting multiple machines for multiple different users to use, right? And so there's a lot of services and abstractions and technologies built in the cloud platforms, whether it's AWS, Azure, or Google. And that's all stuff that's a whole like industry of itself, again, and to learn and understand those security and privacy considerations. And so, of course, your organization, if they're on the cloud, they have teams of people dedicated to that. And then at Saturn, kind of we have a team of DevOps engineers who are building this and ensuring the security is there and all in place, trying to make it, again, as seamless as possible for other people.
Mm-hmm. Absolutely. Thank you. We've got a question here from Angel Garcia. So what technologies, tools do you recommend for each stage of the pipeline of data gathering, cleaning, featuring, processing, analyzing, visualizing?
Yeah, and so I'm going to answer this the same way that a lot of questions about data science are answered, and it depends.
I was just going to say, it depends on the case study, right?
Exactly, but I can give some kind of like quick, brief kind of scenarios, I guess. So, and this is kind of stuff that we see at Saturn and I've experienced in my own career, is you get one scenario is there's some large database that your company has, and it's pretty big. You need to execute some query on it and just like process it, just like go through the data, clean it, figure out what it is, what it means, cleaning it, right? So that's just like the cleaning and feature extraction phase. Let's say if that's like a pretty large database from your company, you'll need tools like Dask to do the cluster and parallel computing. If it gets to a point where once you identify like some sort of population or set of observations where you want to do your machine learning, and it's small enough, it's a couple million rows, a couple gigs of data, and that fits into like a pandas, NumPy, scikit-learn kind of paradigm, you should totally do that. And that's what's great about these tools is they all work well, passing them off to each other. You're not having to go into different worlds and different ecosystems. So, and let's say you have a pretty simple model that you need to train, and it works fine on with scikit-learn. Go ahead and do that. That's perfect. And then kind of whatever visualization tools you might use there. A kind of a flipped scenario is where you have like a data set that fits reasonably well in memory. Maybe it's some sort of like NLP data set on not a lot of records, or any kind of data that you might use, and then you need to do some like really intensive feature pre-processing or really intensive machine learning. So let's say you're training like an XGBoost model or a random forest model, and then before that you have like all kinds of like crazy kind of custom business logic to generate features, and that stuff is all like really, really slow from a compute perspective. That's where you're going to want to pull in something like Rapids to make it faster, or something like Dask to parallelize that, or both to make it faster in parallel.
Right. All right. So yeah, thanks for that. I know it always depends on the situation, but it's always good to hear a few examples. We've got a question here from Matthew on what resources would you recommend for getting started with Saturn and data engineering?
Cool. Yeah. So as far as Saturn, like you can just go to saturncloud.io. If you really want to get into it, you can go to saturncloud.io/docs. That'll kind of give you everything that you might need to know about using Saturn, kind of how to get going with it, and things like that. And then data engineering. So I'll answer the question as if they were separate things, but then also together. So like data engineering is like a great field to be in. It's like super in demand. I consider it as part of like the data science bubble. But then especially it's a specialized part of that bubble, because data scientists are always working in a team, right? Not everybody's gonna be able to cover everything. So data engineering resources for that, I would say, is kind of look into like database systems and SQL. And off the top of my head, I don't know, like there's this one course that you should take on data engineering. I know the ones for data science, but data engineering, I don't know them off the top of my head. But then doing them together, I think Dask is a great place to look at doing data engineering in Saturn. And then there's another tool that I haven't mentioned called Prefect, which is a workflow orchestration tool. And because I've been kind of focusing a lot on like parallelizing workloads, but what Prefect does is it lets you set up like series of jobs and tasks that need to kind of execute in a certain sequence. It'll handle failures. It'll handle error messages. If you're familiar with a tool like Airflow, Prefect, I believe, is like the next generation of that, which makes it like a lot less code that you have to write. It handles a lot of things for you. And the best part, there's a pattern here, it integrates seamlessly with Dask. So
there you go.
Yeah, so if you're doing data engineering with Prefect, and then you get to a point where your data is really big, you need to parallelize it, you can just stick a Dask cluster, and specifically a Saturn Dask cluster, up to your Prefect flow, and then it'll actually execute all that stuff on the cluster, making it all super fast. And Saturn has a native integration with Prefect. Prefect is an open source tool for kind of like the workflow orchestration, and we integrate with that. There's also a Prefect Cloud offering where they offer some paid like monitoring and some nice conveniences, where we also integrate with their kind of cloud platform too.
Okay, cool. Yeah, so we've been talking about machine learning and how we can make things go faster. Do you have some use cases that you can share where you guys actually, Saturn Cloud has helped machine learning go quicker?
Yeah, and this is like my favorite part of the job, is because like I get to like tinker with stuff, work with large data sets, play with them, like make it like way faster, and then everybody gets all excited about it. So I love this stuff. And they make for good headlines sometimes, right? It's like, we did this 100 times faster, 1,000 times faster. So,
I know, I saw that slogan on the site. We do 100 times faster for machine learning. I'm like, ooh, that's interesting.
Yeah, and it's not, and I promise it's not clickbait. It's actually like real stuff.
Yeah, that's good to know. Okay, good.
Yeah, so actually one where we have an example of it is we did this exercise of a pretty large hyperparameter tuning workflow. And basically we did this big grid search where the model itself was like a pretty simple model. It's like a linear model, but we had to train a bunch of different models to try different parameters. Okay. And so it was like 400 parameters in the grid, or 400 entries in the grid. With cross-validation, that becomes like 1,000 different models that you have to train. So we ran this on like a pretty big machine with scikit-learn, and it took 3 hours to kind of go through that entire grid. So that's something that, like, if somebody's doing grid search and hyperparameter searches, that might seem normal, that might feel normal, right? You kick it off, you wait for it to run overnight, and then you come back. But like, what if there was an error? And then now you have to wait 3 hours again after you fix it. So those are the kinds of things where you shouldn't accept that that's the case. You shouldn't have to wait for the code, right? There's tools to take care of that. So we did that with Dask by parallelizing to a cluster of, I forget how many machines, but I think we have an article about this. So I think we can link to that.
Yeah, I the link to that to that article in the comments for if people are interested in reading about that specific use case. They can check that out.
Great. Yeah. So we took that like same code. All you had to do is kind of like import Dask, initialize your Saturn Cloud cluster. Same exact grid search took 1 minute. So that's now.
Wow.
Yeah.
That's crazy fast. Wait,
3 hours to 1 minute.
In Jupyter, right? Like you don't have to install anything else. You could just.
No. Yeah. You go into Saturn Cloud. You can actually grab the code, and there's instructions on this code for you to run it yourself. You go to Saturn Cloud, even from inside of a Jupyter notebook. You run a couple commands to spin up a Dask cluster, and that's really the only net new part of the code that you would have from your scikit-learn pipeline. And then you can run the grid search code, and just like boom, it almost feels like magic.
1 minute, yes, that is like magic.
There's an even better one though. So another one that we did was so that was the case where I talked about how like your data might be small, and then you just have like a lot of models to train, right? Mm-hmm. The random forest is actually a case of more of both of that. We did random forest, like a single random forest model training, but it was with 300 million records. So quite a lot of records. Like, most of the time, that's like a lot of data. Like most of the time, you try to import that and run it in scikit-learn. It's like, it's either going to die or it's going to like take forever and ever. So it's like, so we didn't even have a scikit-learn benchmark for this one because the data was so big, right? Yeah. So what we did in this case was we used Spark, which I mentioned as kind of like a previous generation, like big data tools. It's still very popular, but we did Spark with CPUs, and we trained that single random forest that had 300 million records. That took 30 minutes to train. So it's still a thing where it's like, that's not great. And that's one single model. So if you needed to try and like hyperparameters, if you had imagine a 400 item grid of something that takes 30 minutes each. That's a long time, right?
Yeah, that is a lot.
So what we did with that is we used Dask, but we also then used Dask together with Rapids. So Rapids, like I mentioned, is that GPU computing data science platform. And so what that does is it'll train the random forest using a GPU. But the challenge is, same with Pandas, is that you have to load your data onto GPU memory. And so GPUs each only have a limited amount of RAM, like 16 gigs. Mm-hmm. So where Dask comes in to work together with Rapids, and Rapids has this natively, a Dask integration, is you can also spin up a Saturn Cloud cluster, but now these are machines that have GPUs. And we did this with 20 computers that each had a GPU on them, with code that looks exactly like your code from scikit-learn. This random forest model trained in 1 second, like not 1 minute.
Yeah. Really? Yeah. Oh, that's insane. So it's more than 100 times faster.
It's a complete paradigm shift when you get into GPUs. Yeah.
Wow, that's amazing. And I shared a link to your random forest article as well, so people can read more about that. But that's really impressive.
Yeah. Oh, I do have one more, if I may.
Yeah, go ahead. Share.
Yeah. So this one is fun.
Example. So go for it.
Great. This one is fun because this is something that we were able to partner with one of our customers with, actually.
Okay.
So we have a customer called Sensei, and they do a lot of computer vision on videos. Okay. And so, like I talked about kind of before, is that deep learning is that area where you're used to using GPUs in deep learning. Like that's the only way that it really became accessible and possible to train these crazy complex models is with a GPU, right? Mm-hmm. And so what they do is they actually extract features from videos. So imagine, a lot of computer vision is just from an image, but when you're working with a video, that's 30 images per second. And so that just balloons your data size, balloons the computation that you would have to run. So they were doing this feature extraction exercise on like an on-premise GPU machine. So some hardware that they spent however many thousands of dollars to buy, right? And they were processing at a rate of like 90 minutes for a single video to like extract the features from a single video. So when you have like hundreds of videos, that's obviously not great. No. With Saturn, we were able to and this is crazy, we were able to spin up like 150 machines with a GPU to process these videos across the cluster with Dask. So in this case, it was using PyTorch for the feature extraction, but parallelized with Dask. And so that's kind of how you can see how Dask kind of works together with all of these different packages. And so that took the 90 minutes for a single video down to 40 seconds.
Wow.
Single video,
that's
right?
Really crazy.
Yeah, and this is just like a raw pipeline that you gotta have to push things through. So that was something where like to get all their data through, it would literally take 2 months just to run their data through this thing. And
oh my God.
Yeah. So imagine having to iterate every 2 months is just like you really can't iterate at the speed as you might be used to, right? So you take that 2 months down, and the total that it's in the article, the total I think was around like 11 hours. So now that's a thing where you can run all your stuff through, check the next day, run through all your stuff, and it's just like, again, paradigm shift.
Yeah, that's huge. My God, you saved the best for last. That's
Yeah,
really
right, exactly.
So I shared the 3 links for those who are interested in reading the blogs. But we've got some questions here as you were talking. So Matthew's asking, learning how to use specific cloud vendor can get expensive for the individual learner. What resources do you offer to learn Saturn? What certifications are there? Do you have to learn Saturn? Like, tell us more about that.
Yeah, that's a great question. I think that comes from the world where you have to like spend, a lot of time learning how to use AWS, and you have to learn what AWS calls all these different things, or Azure has a completely different terminology for all of those different things. The great part about Saturn is that we run on top of those technologies, right? So we had to go and kind of figure out and learn all of those things. But as a user of Saturn Cloud, all you have to do is kind of sign up, get going in there, and then you don't have to think about that stuff. You don't have to think about EC2 instances or Kubernetes clusters or like security or VPCs or like any of that stuff. You can kind of just bring the kind of Python data science knowledge that you already have, and then you can get going up in there. So there's not really a lot that you have to learn like from a technology perspective. It's more about just familiarizing with what we call a Jupyter server and then what we call a Dask cluster. But it's really light. It's the same way that you might kind of go and sign up for some social media platform and start learning that. You can get working with it in just a few minutes. The same way with Saturn.
Okay, awesome. Thanks, Aaron. So I was looking on Saturn Cloud, and I noticed that you guys launched a hosted platform. So I just wanted to talk a bit about that. What is this hosted platform? Who is it for?
Yeah, and so that's really cool. And so when we're talking about like this new hosted platform, this is in comparison to the kind of enterprise platform. So we have an enterprise platform where you can install Saturn Cloud onto your AWS account. So this is for like very security conscious, like enterprise level institutions where they do have a team that's managing your AWS, and they want to make sure that they have fine-grained control and security and things like that. The hosted platform is for people who either don't have that team or don't want to, I'm not going to say deal, don't want to, who want to kind of play around and learn this stuff on your own and get going with clusters and GPUs kind of on your own. And so really the hosted platform is for individuals, it's for students, it's for even small teams. Kind of, if you as a person, any person can go in there, put in an email address, create an account, and then you get started with a free trial of the hosted platform. And then you can kind of get going. You can spin up, we have examples kind of on there already for you. So all the stuff I talked about with like hyperparameter searching with Dask, using Rapids with GPUs, all of those things, we have examples that you can kind of get going and learning all of this stuff. And then you don't have to worry about it. You don't even know that it's running on AWS. Like you don't have to think about that at all. You just kind of go in, get an account, start working, fire up a Jupyter lab, fire up a Saturn cluster, and then do your stuff. Awesome.
I just shared a link for your hosted platform so people can go and check that out. It's also in the ticker. If people have been watching our ticker rolling the entire session, is there as well. There was a question here earlier about the cost. So Saturn Cloud, is it totally free? Maybe you could talk a bit about that and the differences between the enterprise and the hosted platform.
Sure, absolutely. So Saturn Cloud, we offer free trials, but the cost really comes from the cloud kind of hardware costs, right? So it's like the computer costs something, and then we have to pay Amazon to host that computer, and then we have a small upcharge on top of that to kind of pay our staff, right? So, but the way that the pricing works, it's completely usage based. So there's no kind of like upfront cost. There's no like fixed cost. You're basically just paying for whatever the cloud resources are. And like just for an example, these GPU machines that I'm talking about, they're like 50 cents an hour to run. So and you can spin it up, run it, and then you're just paying for that like usage cost. And it works exactly the same way on the enterprise product.
Yeah, it doesn't seem like it'll get too expensive since you guys can do everything in like a second, right?
Yeah, but the idea then is you're going to continue to do stuff, make your models better because it only takes a second,
Yes. So if people wanted to check it out, like those watching us right now, they can actually go to that link and get a free trial themselves. They don't need any company approval or anything like that, right?
Yeah, exactly. You just kind of put in your email address. You can get going with a free trial. And then the page there, and you can kind of go look at the pricing. We have details on the price. It's a really straightforward pricing model. It's just consistent based on the types of computing resources you're using. And then you can get more information there on the hosted product and get going. It really only just takes a couple minutes.
Okay, cool. So let's say if I sign up for the free trial, should I be worried about uploading like private data? I don't know much about that.
Yeah, no, sure. So I mean, you do have to think about that. It's a platform where it's the same as the cloud, right? There's multiple people on this same platform. So if you have like a really security conscious data set and you're at an organization where you're not supposed to like share your data outward, you might want to be careful with that, right? But we use some publicly available data for the examples. If you have some of your own data that is private, it's not like we're going to go post your data set somewhere. Like it stays within your account, but there's these security considerations of the fact that things are located in the same kind of place. And then that's really where, when you do have these like kind of security conscious and data sets, that you want to go for the enterprise product, because that all runs within kind of your AWS account. Like Saturn Cloud will actually install our software there, and then so you can control everything. It all lives within your environment.
Okay, cool. And we actually had another question here on machine learning in general and automation. So what are your thoughts on automation in machine learning? Are there some steps in the data science process? I know we covered some of the steps already. Are there any that you don't think will be automated anytime soon?
Yeah. So there's things in the data science process that absolutely can be automated. I mean, even something like hyperparameter tuning, right? There's a lot of algorithms now that will then either like intelligently search for hyperparameters and kind of like figure out how to do that. There are tools now like that will kind of run like a whole slew of different machine learning models on your data, and then kind of like find which one's best. So in my opinion, is like those things are cool, but generally like you're not gonna get like crazy lift. Like if you have some tabular data set and you decide to train a random forest or an XGBoost with it, and then you run an AutoML algorithm on it, you're probably not going to get like a crazy amount of performance lift. You probably will get some, but you always has to start with the data, right? You can't train a model unless you have the data, right? Machine learning is data and an objective. And it takes humans to create, collect, and process that data. And then it takes humans to formulate the business problem and the objective that you're trying to solve. So those things, I believe, aren't going to be automated. That's what data scientists do. We deal with a lot of the mechanics of data cleaning. We deal with a lot of the underlying mechanics of, and historically of cluster computing, or like all of that stuff. And a lot of those things are working, getting better. We're continuing to improve them, but we're always going to have that core problem of the data and the function.
Great. So for those listening out there, data scientists are not going away. Aaron said so right here.
Yeah, you can take my word for it.
Yeah, I agree with you. I mean, there will be changes in the landscape, and we'll automate parts of it, but I think you'll still need humans, data scientists. Yes, exactly. We'll just have to work closer with machines and AI and all that stuff.
Yeah, and it's great. That's the tools we build, so we're going to, of course, build tools to help us as well.
Yeah, absolutely. Well, Aaron, I want to thank you so much for your time today. Before we wrap up, I want to just ask you a final question, and that is, where can people go to learn more about Saturn Cloud, about you, about the work you're doing? And if they wanted to continue the conversation, where can they find you?
Yeah, so I mean, of course, the best place for Saturn is saturncloud.io. That's our website. Our blog's there. You can find out and kind of keep up to date. You can sign up for our email newsletter. You can also follow us on Twitter. I think it's Saturn_Cloud on Twitter. Like if you kind of want to reach out to us, ask some questions. Myself, my Twitter username is RIKTURR on Twitter. It's a little play on my last name, but you can kind of find me there. If you want to shoot me an email, even it's just Aaron@SaturnCloud.io. Feel free to reach out with any and all questions. Or find me on LinkedIn. We're on LinkedIn now, so it's like we're on LinkedIn now. And anywhere that you can find me or Saturn Cloud on the internet and shoot us a message, we'll definitely get back to you.
Awesome. Thank you so much. Well, it's been a pleasure, and I love learning all about all these cool new tools that I need to become familiar with. So thank you so much for your time again.
Yeah, absolutely. Thank you.
All right. Bye.
Bye, everybody.